So today we're going to talk about inheritance and the prototype chain. I just want to warn you that there are some very, very nuanced differences that we're going to go over today. So please, I really encourage the questions. This is for your understanding. You should be sitting there going, I got it, I just want practice. If you're a little shaky as to like what something is, I'm going to try my best to ask for you questions, and if you're identifying with those questions that I ask, just go ahead and be like, yeah, you know what, I don't get that. And you'll see that a lot in this lecture. We're going to talk about inheritance in the classical sense and inheritance in the way that JavaScript does it. And so inheritance, I'm just going to define it for you. Cool? It's just when one object, all right, can you see this? Is that better? All right, when one object gets access to the properties and methods of another object. You've seen this in Ruby, seen this in very classical object-oriented programming languages, right? You have this dog class that inherits from animal, and they all have the function like breathe, or they have this method walk. Even though it's not defined on the dog class, if it's defined on the ancestor or the parent class, then the dog class would have access to the methods and the properties of animal. Does everyone follow me so far? Are there any questions on just how that classical inheritance works? All right, we've seen it like this, where I can simply, this is like a class, give you 2 seconds to kind of orient yourselves. Do you remember this? Back in Ruby land? Oh, look how clean that is. God, that sugar is out of control. All right, you have this initialize, and I want to highlight the initialize is a very special method. You can't use initialize for anything except initializing a new instance of this class, right? And if I spell it incorrectly and I do robot.new, will it read this? No, it needs to be spelled very specifically in this way. And that's going to affect JavaScript as well. So you simply have these, and then you can just inherit like this from some like, I don't know, parent class. Right? I'm sorry, is it? Yeah, Ruby syntax is, no, it was the other way? Oh yeah, you're right, it's like this. Yeah, right? Cool. Are there any questions in classical inheritance and it just being able to, if there was a method defined on parent class, can robot call it? Yes, you've seen this with the application controller in Ruby. Remember I defined all those methods on the application controller, which was the parent controller, and all the other controllers had access to those methods, right, because of inheritance. And so here we're going to go a little differently into how JavaScript does it. What we're going to do is we're going to create some objects in JavaScript, right? And what we want to do is we want to create a bunch of these robots. In the same way that Ruby, it would just be the old robot.new, and then you pass in name, weight, and speciality, right? Any questions on like just this new instance of robot? Great. So let's try doing that in the way that we currently know now in JavaScript. Here we just have object literals, right? I can just do const, I can do robot1, and I can just make a brand new robot. And that's just going to be a name. Any like robot names that we like? Huh? Michael the robot? Okay. Michael, right? What's the weight of Michael? 2 tons? Powerful. And what's the specialty? What does Michael do? Painting, right? Yes. Cool. Are there any questions as to how I just created this brand new object? Pretty easy, right? I'm going to do robot2, and let's put Bob Ross, and he is 1 tons, right? And better at painting. Cool. This is just the object literal syntax. The problem with this, as you can imagine, is very, very prone to errors. in the same way that I can do the same thing in Ruby, where I can just make this brand new object without the class syntax. And so look, it is tedious and error prone. This is very slow because I have all these shared attributes across all the robots, right? So when I say shared attributes, is this sort of making sense now? Cool. What we want to do instead is possibly have something called a factory function. So you can imagine, right, that all I'm going to do is, I'm like kind of writing similar code. If you want, we can go divert off robot, but I want it to follow the README again, so you can kind of reference that again. So I'm just going to make a function, and it's going to be called the robot factory. Because they, wow, that's terrible. Because they all share those same properties, I can simply give it the name, the weight, and the specialty. Right? And all I'm going to do is assign a brand new robot. And here, the reason I want to go over this is because this right here is the brand new ES6 syntax. And notice how the key value pairs are exactly the same. Meaning, if I want to assign this robot a name and I want to give it this name, I'm going to copy it and paste it just so you can see that it's exactly the same. And then I hit comma. I can do weight is going to be whatever weight I pass in. And then the specialty, same thing, is going to be whatever specialty I pass in. Are there any questions on to how this is written? No, right? Oh. Yeah, that'll break it. Cool. Thanks. Other questions on how this is written? Yeah.
But won't that every want to make the robot, it's constant robot. So like if you pass every time you run robot factory,
It'll give me a new robot object, yeah. In the same way that I can just const robot1 and make an object literal, I can have a function that creates these robots for me, and all I have to do is pass in the name, weight, and specialty. In the same way that Ruby does it, right?
I meant like, because you're calling it robot 1 or robot 2, but here it's just robot and it's only.
Oh, right. This is just a placeholder because then I will do const robot3 equals to robot factory.
Okay.
Right? So in the same way that I can do robot.new here and then just pass in name, weight, and specialty, it's less prone to errors. It's less tedious. I can do, let me just refactor this super fast. The ES6 version of this will just be just like this, but because the names, the keys, and the values are exactly the same.
Oh, they gave you some sugar. That was nice.
Yeah, this is some sweet, sweet syntactical sugar. And this will be exactly the same. Are there any questions to this? Cool? Great. And so, in the same way that we can just pass in the name specialty, right? I'm going to wind up doing this right here, right? I can just pass in robot factory with the name. So I can have like T1000, right? The weight is 0, liquid metal, can have no weight, it's weird. And it's from Australia. Cool. Yeah. What would happen if I ran Robot Factory right now as it's written? What are we missing? That's right. I need to actually return the robot. Cool. And this way, my Robot Factory is sort of mimicking how Ruby does it. Right, I just pass in the name, the weight, and the specialty. And that way I can just do robot 4, and then I can just change this, this, and this, right? So T2000, it got heavier, gained weight, and it's bad to the bone, right? Cool. It's so much easier. There's less to type out every single time. I've extracted all the keys out. Yeah?
So if you were to rewrite the robot factory function as a ES6 one-line custom return function, could you just have that curly braces name, weight, specialty in there?
What do you mean?
So when you write an implicit return arrow function.
Oh, you mean just like this? Get rid of robot, just return this right here?
Yeah.
Yeah, you can do that. I wanted to be a little more explicit. So the question is, can I just rewrite this on one line with the arrow function? Yes. Right? And so let's take a look at what that is in the console, right? Cool. What is robot 3? Just the object. Cool. Like no real difference from, oops, yeah. Great. Let's keep going. What I want to talk about, and this is where it starts to get really like wacky, is I want to add functionality, right, to this robot. So in the same way that Ruby did it, I have a method called recharge battery. Does that make sense? And I just put it right inside this class so that every single robot that I make has a method called recharge battery on it. I can do robot1 equals robot.new. And I can pass in a name, I'm getting lazy here, a weight, and a specialty. And then robot1 has access to recharge batteries. Oops. Right? I don't need this back in Ruby land. Cool. Are there any questions in like how that happened? Look pretty familiar, right? So here, what I want to do is I want to create this function called recharge batteries. I want to give it a robot, and that way it will simply print out the name and it's recharging batteries. Are there any questions as to what this does? We can take it one step further, right? Because I'm not going to write this out. That's ridiculous. We can take one step further, and inside this robot factory, I can simply add in, instead of name, weight, and specialty, I can add in an extra key that will give me that function. All right? So let's do that. Right? Do you see now how in here, right? The main difference is that I'm adding in, I added these like spaces in here to make it look more readable. But I added in this recharge key. It points to a function, and it just does this.name recharging batteries. Yeah?
Is this how the window like kind of works? Like the window is an object with other things attached to it, like it could be a function.
Yeah, the window has a bunch of functionality to it, right? So here, right, let's do this. If I were to do that, does robot 3 have access to this key? All right, let's check. Robot 3 dot recharge batteries, and it's just some function. I can invoke it, and it'll give me T1000's recharging batteries. Are there any questions on that? I know it's moving slow, but it becomes really confusing. So I want this baseline to be like unquestionable. So every single time I make a robot, let's say I make robot 4, right? And this is T2000, 10, also from Australia. And if I go robot 3 and I do robot 4, they both have this recharge batteries function, right? So I can do robot 4 dot recharge batteries. It'd be good to go. When I created this object, recharge batteries is a function that I've created and defined on both of those objects. Are they the same function? So what I mean by that is robot 3 dot recharge batteries is a reference to a function, and robot 4 dot recharge batteries is a reference to a function that is exactly the same. However, They are separate functions that do the same thing, that were created and defined on two different objects. Is that an effective and good use of your memory? No. Wouldn't it be nice if I have some function called shared, right? Or rather a variable. Let's just do const shared is a function, and it just says I'm sharing and caring. Cool? Wouldn't it be nice if I did robot3 and I said something like shared functionality? Shared function is shared, is a reference to that function. And then I did the same thing, except robot4 gets it. Notice how shared is just a separate function that lives outside of both of them, and then both of them point to the same function, right? So if, as we learned in day 1, objects are passed by reference, not by value. So robot3.shared shared function strictly equal to robot4.shared function. Yes, because they're both having the key of shared function pointing to the same place in memory. Shared is different and unattached to the object. It is pointing to it. Does that make sense? Let me draw it out for you. If I have an object, right? Let's just do this. An object, right? And it's got some keys on it. And I have this object, right? Object 2. And it's got some keys on it. These keys and these keys are not the same, as we've just witnessed. If I have some sort of shared function, and it's like its own object, and I say that key number 4 and key number 6, whatever that is, doesn't matter what it is, point to the same function, is this going to be the same for both? Yes, you can visualize it now, right? It's different. So in order to do inheritance for JavaScript, I want to create this separate object away from my objects and simply point them all to the same function. And that way, object 2, object 1 and object 2 will have the definition of inheritance. And that is, it has access to shared functionality and properties, and it's not necessarily attached to each of those objects. Does that make sense? The reason we do not want to do this, as a complete reiteration, is because it will take up too much memory. If I have 7 robots, I've just created this charging batteries 7 times, even though it does exactly the same thing. I want to create this separate function and then point all 7 of these robots to that one function. Are there any questions as to functions being passed by reference, not by value, and how it is useful to extract functionality, shared functionality, to a separate object? Yeah.
At what sort of scale do you start to notice these sort of memory inefficiencies? You said that one, constantly resetting or having to use a new memory location for a function is inefficient. Like, at what point is that actually noticeable?
At what point is it noticeable? That's hard to say. It completely depends on your system. So the question is, at what point do I create this function, like 10, 20, 100, 1,000, a million times, will I start to see a slowdown in my application, right? To be honest, I have a MacBook Pro. Some of you have MacBook Airs. Some of you have the newer MacBook Pro, some of you have a MacBook Pro from 2015, right? If I host this code on like a really crappy server that has like 1 gigabyte of memory versus if I buy a more expensive server that has more memory, I will see a difference based on that, right? And so it's hard to say like generally in the thousands, right? It's really based on the system that your code is running on, and then ultimately it's something like this that a more senior dev will kind of look at and review and be like, hey, this is how JavaScript works. Let's do it this way, save memory so that we can buy cheaper servers, have the same speed and functionality of our website, and save the company money. And that's kind of like these things that we want to make sure we empower you with, the knowledge of how JavaScript is working, the benefits to it, taking advantage of things like pass by reference and pass by value to maximize the efficiency of your code and then ultimately be a better developer, right? So it doesn't really matter like how much you can do as much as I know what the tools are and I can build anything. So I didn't really answer your question, but it's about scale and relativity. Is that fair? Yeah.
Are you gonna hit some kind of problem when you use it functions outside?
If you remember from yesterday's lecture, this is all I did, and watch this refactor. So remember, I want this shared functionality, but not defined on this robot factory. So I'm simply going to go, bloop. Missed you guys. And I'm going to take this. All right. Am I in JavaScript hell somewhere? Oh, yeah. Whoa, zoning, cool. So I can then do robot 3 dot something, like whatever key I want it to be. I can customize this key because I'm just assigning it a new key. So I can call this, I don't know, let's just call it Andrew. And that is going to be pointing to Andrew, wow. A reference to the function recharge batteries, and robot 4 can have Chris pointing to a reference of recharge batteries. And now robot 3 dot Andrew, whatever, I'll fix this. All right, is that strictly equal to robot 4 dot Chris? Absolutely. I spelled something wrong? Oh, yeah. I'm losing it, sorry. Good catch though, all right? Like it proves to me you're paying attention, and that's good. So this will be, in fact, true. So these are nebulous, right? They're whatever keys you want. It makes sense that they're both named the same though, so I'm gonna take away this Andrew and Chris because it's just kind of confusing, and I'm just gonna put like, okay, recharge. Cool. I just wanted to demonstrate that the keys do not have to match, but they should because it's more readable and it makes more sense. So now the question that you had was, if I were to do robot 3 dot recharge batteries and invoke the function, if you remember from this lecture, this dot name, right, is created, the context of this is created at the time of invocation. So even though in this particular function, lexically, it is sitting on the global object, and it's not nested anymore inside of, like, say this. When this gets called, when it gets invoked, it is invoked on robot 3. So robot 3 dot recharge batteries, this will point to robot 3. So this will have the same functionality as it did when it was defined inside the object. Because of the power of this, and when it is invoked. Does that make sense? So I want to take 2 seconds to just say, are there questions as to how and why I extracted robot batteries outside of this factory, why it's more efficient, and why it still works even though this doesn't have the correct context at the time of declaration. Yeah.
When you call robot read out recharge batteries, is that you're calling it by the name of the function that you define rather than what the key that you set it to?
I'm sorry. Ooh, wow, you're totally right. It should be recharge. So sorry, because this is the key. Good job.
Can you explain the last part again?
Yeah. There's no way it would have access to recharge batteries.
Right.
It should only have access to recharge because I'm assigning it the reference to function. Yeah. That autofill. I mean. Cool. Are there any questions on so far why we did that? All right. So I want to go into something that's pretty important. This is where it starts getting like mind bending. And so I wanted that solid foundation of how it's going on. Yeah, you like that? Cool. This is just, again, Ruby's classical inheritance. And the reason it's called classical inheritance is because it's always been done this way. This is the way it's classically been done. It doesn't actually have its own name, but now that there's a different way to do inheritance, they've just referred it to as classical, and this new type of inheritance is called prototypical, and we'll get into that right now. So, JavaScript does not have classes in the way that Ruby, Python, Java has literally this keyword class, and it is a blueprint for these objects, and it's going to receive a argument in the initialize method, and then share all of those methods. JavaScript does not have that. So we'll learn in a second that JavaScript has a keyword class, but it's fake. And I'll explain. So they have something called prototypical inheritance. What that means is, if you remember this amazing diagram, which will very, very obviously clear. Should I just do a new one? Yeah, I'm gonna do that. Cool. So what we have is a function, right? And there's a couple things about this function, right? It could have a name, right? Or it could be anonymous. So this is what separates a function from a regular object. It has code, right? A regular object does not have code. Does that make sense? Like, it doesn't have an executable line of code, and this can be invoked or called. Does that make sense? The last thing it has is something called proto, which is just short for prototype. Cool? Are there any questions on that? This is like the third and final thing that functions have as specialties. Now, in order to do inheritance properly, you should be able to inherit from more than one thing at a time, right? Which means that this proto on this particular function can have its own proto. And that can have its own proto. All the way down till when it gets to the last proto, which is capital O object. In the same way that Ruby does. Do you remember like calling dot class and then dot class dot ancestors? It goes into something like string, right? So the array can have something like kernel and then object, and then goes all the way up, and the last thing at the top of the Ruby chain is capital O object. That make sense? We learned about bind, call, and apply yesterday. All right, a little shaky on it, but still learned about it. How does the function have these methods already defined on it. Let's take a look at this code. If you remember, I have this function here. I can just console log, right, robot. And in here, I have name, specialty, weight, and something called underscore underscore proto underscore underscore. The reason it was named like this is because do not accidentally write to this. If your code somehow goes const awesome equals to some function, right, like whatever, like robot1, and then you go underscore underscore proto underscore underscore, and then you tell your boss, I wrote that by accident, you's a liar. That's really hard to write by accident, right? Okay.
Is that like monkey patching?
It is very much like monkey patching, right? That being said, sorry. The underscore underscore proto is pointing to the prototype object that has all of the shared functionality. Does that make sense? So, as an example, this right here, imagine this was just one large object that had multiple functions in it, right? So I can call const, right? Prot, because I don't want to overwrite it, is equal to like all of these. I will need another one of these. Cool. And this is like function 1. And then this is going to be, gross, right? Function 2, and just some other function, right? Like another function. Boop, 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 and it just console logs. Who does number 2 work for? I can have this robot factory point to this prot, or this proto here, and it would get all of these functions. Does that make sense? I have access to func 1 and func 2. So, what I'm trying to say is, inside this app, I can have a proto that points to a proto, that points to another proto. If we go back to here, this proto is coming from the object prototype. So it's not nested yet, but right now it's just pointing to the object. So you can get, set, you have your own property. This is like the classical inheritance, like vision, where I have access to everything, all the functions object can do. In the same way that I can just do an array. It's the prototype of the array. And now every single array has access to entries, every, find, map, because it's inheriting all of it. I never defined .map on the array, right? It's on its prototype, so that every single array points to the same .map function, points to the same .each function. I don't create a brand new for each every single time I create an object. It points to the same function in memory. Are there any questions? Who's confused so far as to just that pass by reference? The proto is a separate object. Cool. So I have unshift, slice, we know and love, right? So far so good on the underscore underscore proto and how it kind of looks like this. It's not exactly the same. Here's where it gets real dicey. Cool. Ready? A link is made between the object instance and its prototype, which is the underscore underscore proto underscore underscore. Are there any confusion as to what I mean by the object instance and a link is made? Who here feels like they understand what that means? Cool. I'm just simply doing this robot factory function, and I can assign it prototypes in the same way that I did right here. Boom, recharge batteries. Well, now this code is not going to work because I wrapped it in this prot. But if I pointed it to prot, it would have access to function 1 and function 2. Right? So let's get rid of this, because this looks crazy to me. This is just for demonstration purposes. So the rest of the code will work. Cool. So there is something else. Right? Are we good on this syntax so far? Looks just like this. Okay. There's something called object.create, and we will mess with that and how it's different from the new keyword. Who understands the new keyword in JavaScript? Have we gone over that yet? Let's do that. So I'm going to copy this code. Now I have all of this, right? I have a robot template, this refactored code that we pulled out. Actually, this is the same as this, right? Let's refactor this together. How would I have robot template not create a brand new function every single time? Okay. Right. And now it's like completely out. Does that make sense? Like this function is no longer attached to this robot template. Cool. So if I make a robot template, it does not create a new function in memory. Nice. What I want to talk about is something called object.create. Let's take a look at, this is like robot 5, right? Let's take a look at what object.create does. Oh, I missed it. Where's my spectacle? Here we go. Cool. Great. So I have const.
Is this like, sorry, is this like in comparison to like the typical like literal syntax or like the new operator?
It's different, and I'll explain.
Okay.
Oh, did I not save it? Oh, yeah, that's right. Smart. That's fine. We'll leave that alone. Cool. What is robot 6 now? Here? What do we have here? It just points to all this. And this prototype points to the object prototype. Cool? So far, so good. If I were to look up robot 6 is _ proto, it's just going to be all of the functionality that it has as defined inside the template. Which makes sense, right? So far, so good. If I wanted to, this code is not going to work now, right? I would just reference it here. I would want to assign this in this prototype. Ignore this. In order to get access to this outside functionality. It's literally what we just did. I want to show like multiple examples. Right? So if I were to do that, except I want want to change it to 6. I now have robot 6 can do this recharge batteries function. It's supposed to be null because I assigned the name to null in the beginning. Cool. In case anyone was like, oh, it didn't work. Are we good on this? Right? Thumbs up. Awesome. The last thing I want to do is have something called this new keyword, which is going to be where it gets dicey. Let's do this. We have the robot factory from before, right? Except this time, I'm going to put this in front of it. So all I'm going to do is, now I'm going to put this robot factory. Cool? Just so it's different from the original robot factory. Something I want to point out that's very important is in the same way that earlier, where did we do it? We did this robot factory that spat out this robot. This basically creates objects for me, right? In the same way that I can just do the object literals. Did that sentence make sense? That this function just creates objects for me. If I pass it in 2 strings or 3 strings, it will give me back an object. Right? If you have a function that simply gives you back an object, this function constructs objects for you. This is known as a constructor function. Is there any confusion as to how I made that large leap? Cool? If you are writing a constructor function, some key notes. Do you see a return value in this function? No. I don't know how to phrase the question. If you're writing a constructor function, I'm just going to tell you, you should capitalize the first letter of that function. In the same way that this template is going to create objects for you, this class syntax, in order to differentiate it from something else, you put the capital letter on, right? If I'm going to write a constructor function that's going to simply be used purely to create functions for me, I will capitalize it so that everyone else that is using this function understands that this will be used as a constructor. There's literally no difference in the syntax. There's no real way to tell, aside from the fact that there's no return value, and I've capitalized this. That's really the only way. So, if that's being said, how can I leverage this? Right? Because this right now is not pointing to anything. And I will never do something like robot 7 dot this robot factory. That syntax doesn't even make any sense because one, robot 7 doesn't have this function attached to it. And two, if I'm going to make a new robot, I can't have an already existing robot call a function to create another robot. Do you follow me on that? So, in order to get around this, you will use this new keyword. I'm simply going to explain to you what this new does, and you essentially have to just memorize this. There's no, I don't say memorize very often, but you just have to memorize the rules. In the same way that you learned this yesterday, those are just a set of rules you memorize because you have to know how it works. Does that make sense? Okay. This is where it gets dicey. Sorry it's been so slow. What new will do is it will create a new object, assign all of its values, all of its key value pairs to whatever this tells it to do. This looks very similar to this? No? Who thinks they look pretty similar? Looks pretty similar? Because they are, right? When you think initialize in Ruby, I want you to think constructor in JavaScript. Cool? Constructor in JavaScript, initialize in Ruby. Associate them. Not like this in self. That's a little trickier. But constructor and initialize. So when I do this, let us take a look at what happens. What is robot 6 specifically? Oh, I didn't make 6. I just jumped. Embarrassing. What is robot 5? Let's take a look at this. You see all this? And then it points right to the proto, its own proto, that's not named. And then that proto has object. So, what about robot 6? Okay. Do I not have the code here? I gotta hit refresh? It's fine. Robot 5 returns object. Robot 6 returns this robot factory, which is this function here, this constructor function. And it's like this. Of course they're undefined, right? When I defined this robot factory, it's looking for what? Did I give it a name, weight, or specialty? No. So what did JavaScript do? It just assigned them as undefined, right? This should not be surprising to you from our day 1 lecture. JavaScript doesn't know what to give it. It will just go, great, I'm going to store it in memory and give you undefined. So this proto points to object. Constructor, this robot factory. Cool? Any questions so far? It should have been a lot of information to take in. So when I use the new keyword, it creates the new object for me in the constructor, and then it points the prototype to the constructor. It points the prototype to the constructor. So let's actually give it a name. What kind of robot do we know about? Yes, nice. Mega Man, right? How much does Mega Man weigh? 100 pounds? 100 pounds? We should get on the metric system, but whatever. Right? Absorbs power. What a boss. Cool. What about robot 7? Sure, we'll go with 0. We'll stay in this theme. 0's slightly heavier and has like the Z saber, right? If you don't know what this is, don't worry. There's just random robots. It's like really it's unnecessary. All right. Let's take a look. Let's look at robot 6 and robot 7. Cool. They have their own prototype. Right? This function. So, how would I add a method to this robot factory and not define it inside the factory? Because if you remember, if we define it inside the factory, it will create that function every single time I make this new object. We know that robot 6 has a underscore underscore prototype, and that is the constructor of the factory. The factory this robot factory has something called a prototype. And it points to the same object. The prototype is on the constructor function, and each individual instance has access to that constructor's prototype through the underscore underscore proto. Are there questions as to why this is prototype and this is underscore underscore proto? They will point to the same thing. Yeah. That's good. If you get it the first time through, congratulations. This takes a long time to sink in. On the instance, how does the instance, how does the instance have access to the proto? The instance is underscore underscore proto. The factory itself, the constructor itself, has access to the object called prototype, and those point to the same thing. Here's some clarity. In order to create shared functionality between Robot 6 and Robot 7, if in fact what I say is true, that would mean that this robot factory dot prototype dot some shared function, let's just say ahem, very good, right, is a function, and all this function does is log I'm being shared. Cool? What this is saying is I'm defining on the prototype object that Robot 6 and Robot 7, the instances of this robot factory, both point to the prototype. I can call ahem on it. So, right? Let's just take a look at this code here. Right? I put them on. Sorry. So, is that better? Can you see both? So, robot 6 dot ahem is a function. Because they're both pointing to, and that is annoying to type. Can't type it by accident. They both point to the same constructor function. So, sorry. They both point to the same thing. So if I define something on the constructor's prototype, all of the instances will have access to it because this proto points to this prototype, this object. So that means that robot 7, answer your question, also has that, and it's being shared. And they are pointing to the same point in memory. Yeah? You got a question?
Yeah, before you added the prototype just had the constructor.
The prototype just had, yes.
Right. So, I understand why robot underscore proto is pointing to.
Okay, remember, the robot is the,
Showing the function itself on this robot factory.
it looks like it's showing it, but what it's doing is robot 6.ahem is the same as robot 6 dot underscore underscore proto. So the reason it hides this from you is because it wants to look like inheritance. It will shield you away, because what it will do is when I call ahem, the first thing it's going to do, is it's going to look inside. Do I have that key on me as an object? No, I don't. So I must look up the, or down, whatever you want to think about, the prototype chain. So back to this amazing example. This is robot 6. Do I have a hem? No. So I look in my proto. Does that have it? Yes. And I will execute this function. Right? So the cool thing is that this is robot 6 and this is robot 7. And I call robot 7.ahem. It will look on robot 7. Do I have a hem? I have name, I have weight, and I have specialty. Is any of them a hem? No. I will look at my prototype. That prototype is the same prototype that robot 6 is looking at. And that has a hem. So check. And it will execute that function. Huh? That's how JavaScript's actually built, yeah. Yeah, it's built on the prototype chain. Right? So to see how this is like linked together and it looks like a chain, that's where it comes from.
When you do dot prototype on it though, it says a hem and then any other state functions you were to add to it, right? But why is the first thing in there constructor? Can you do robot?
I can call robot.name. I can call robot6.specialty. So they are separate, right? Robot6.name and robot7.name are different.
But like this robot factory dot prototype says a hem and constructor.
What?
Why? What is that constructor part? Can you call that?
I'm sorry, say again?
Under this robot factory dot prototype.
Yeah.
It says that like towards the top of your console it says a hem as a function referencing a constructor.
Yeah.
Right above that. So what is the constructor? Can you do prototype dot constructor like you can do dot a hem?
Sure.
See what I'm saying?
Yeah, you're talking about dot constructor.
Yeah.
It's just pointing to the constructor function.
Okay.
Yeah. Good question.
Because let's say robot 6 dot underscore underscore prototype underscore underscore and this robot factory dot prototype are pointing to the same place.
Yeah.
If you did robot 6 dot that dot and then entered in something else and put a new function, would that also go to everything?
You can monkey patch it. I can, in fact, attach things to the underscore underscore proto. Do not do that. Do not attach anything to the underscore underscore proto. It would take a very long time to explain. You'll get a similar lecture in Mod 5, but because it messes with the way JavaScript will automatically look up down the prototype chain, it slows down significantly. I have never seen it because the one time I wrote it, my senior dev was like, let me show you the prototype chain. And told me that it was bad. I looked into it. I Googled it for a long time. There are performance issues with overwriting the underscore underscore proto. What you want to do is put it on the prototype of the constructor function. In that way, the JavaScript engine will look at the prototype chain properly and execute methods in the way that it efficiently knows how to execute. Does that answer your question? Okay. Yeah.
Just to clarify, so robot 6 and robot 7 objects they're different, except at the prototype point where you created that hand. So any functionality in there, right now you have console.log, they are going to share that functionality. You go and change that will apply to both because they're referencing that same. But the other stuff like name
Right.
is their own.
Because the constructor, I pass it in its own unique values when I initialize it. I have this new keyword. It will share everything on the prototype, but it will keep its own unique attributes.
So it's all about options, so you don't have to change all this stuff for each one.
Right. So in the same way that Ruby likes to do it, right? They share all the same methods, but each one of the initializers gives it unique information. Cool? Who's feeling pretty good about prototype chain and inheritance? That's good. Yes.
Are more languages built like that class, like the push from JavaScript to that, is that more common or is it just wanting to?
Classical inheritance is significantly more common. As far as I understand, and this is like, you can just Google check me. I think JavaScript is the only language right now I know of that's popular and backed that does the prototype. So pros and cons, right? This is for classical inheritance. The pros is that it is the same everywhere, right? We know how that works. You learn it once, you can do it in any language that has the classical inheritance. It's easy to see and understand, but the cons to it is that it gets really, really jarbled. What I mean by that is, as you start to already see in your Rails apps, when you start inheriting, and things inherit from things, things inherit from things, things inherit from things, what can happen is it becomes so tied and nested together through the inheritance chain that if you were building a class house, right, and then the bathroom inherited from house, but it also inherits from room, but then house has to inherit from room, so you inherit the bathroom from the room, that inherits from the house. It gets dicey, and then it gets to a point where you can run a function like turn on the shower and it will flush your toilet because of how nested it becomes. The prototype separates everything into its own separate object, then you just add functions to that object, and then they just all point to the same object. So it's a little bit cleaner, a little bit easier, but a little bit harder to grasp and understand at first. And so there's pros and cons, right? But because JavaScript is passed by reference, it can do it, whereas Ruby cannot. Yeah.
What's the difference between that? So Ruby is single inheritance, right?
Classical inheritance, yeah.
And then, so JavaScript, this is mimicking single inheritance?
No, this is a completely different type of inheritance called prototypical inheritance.
Okay.
Cool. The last thing I want to show you, and we'll go to lunch. Your question?
What would you use this for? I can see how it would be useful, but like, what's the practical?
Very good question. Let's get into a little bit of the practicality and transitioning smoothly into, do you remember, I can't remember if it was me or Andrew introduced, how we've defined JavaScript, and that is a multi-paradigm language. What that means is it can be functional, as we've seen, or it can be object-oriented, or it can be both. I can have some parts of it being functional and some parts of it being object-oriented, and we're going to get into that. Cool? So let's see how this constructor function could be useful to writing functions, using inheritance, and then being more like Ruby in the sense that it is easier to visualize a pattern you've already seen.
Now I actually understand why you could actually write backend with this.
Yeah, great. This is the class syntax. So, this should be commented. I can, in fact, do like class robot, it doesn't matter, I have this character here. Cool? Notice this keyword class is highlighted and the capital letter following. I haven't said this in a long time, but it looked like a Ruby.
Yeah, baby.
Throwback. Remember I said that initialize and constructor, you should relate them? They're not exactly the same. We're not going to go into sort of the differences, but you can, for your purposes, see them as very similar. Name ability, name, weight, specialty. This dot name, I mean, looks pretty Ruby-like to me, right? And then here is some important things I want to walk away with. What does this look like to you with these bananas? I did not, in fact, write function walk. I simply said walk. In the same way that I'm just defining methods on this robot, this right here will add onto the character.prototype.walk. That's what this is doing for you syntactically. Who understood that just now? Oh, wow. Great. One more time. One more time. Here I did this robot.factory and I added an extra function outside of this factory. What I want to do is inside the class, I want to be able to define the methods in the same way I define them here. This looks like a function that does this. Does that make sense now? Thumbs up, thumbs down. Cool. So this is the object-oriented version of JavaScript. Cool? Remember, if you put keyword function here, it will yell at you. It doesn't like that. Cool? So the last thing I want to talk about is how to create class variables and how to create private. So as you remember, here I can do a class variable, class method called self.classMethod. Wow, it's so easy to write Ruby. So easy. So easy. Delicious. Cool. Cool. Here, if I wanted, right? Because remember, in here I have a Terminator, which is a new character, same keyword new. I can do Terminator.walk, and it will execute this. Are there any questions as to how I got there? This and this. Cool? Right? I mean, like, man, that is looking looking like a Ruby, right? So if I wanted to do something like character.classMethod, I simply have to just go static class method. Classy. This static keyword before a method name will give me the class syntax that I'm looking for. Cool? Any questions? It was really just like add static here, and then you get to call it on the class. I mean, it's like adding self, and then I get to call like robot.classMethod. Boop 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 boop.
This is more of a sort of question about the greater structure of web design. So when we're essentially making our own Rails backend and JavaScript frontend, say we have a bunch of objects in our Rails backend, maybe like a relationship of some sort, and then we're fetching them all in JavaScript. How common is it to rebuild the classes that we built in Ruby and Rails in JavaScript that we can use once we import into this object?
That is a very heavy question, and I will simply answer with, it depends. Right? If it makes more sense for the code to be more readable and performant in the way that it's written in class, the senior engineer, the architect, will determine whether or not it's worth that refactor. And that is not something at your level you should be sort of like being able to determine. That being said, this is vanilla JavaScript. All of these principles, while we do not test you on this, right, inheritance in the prototype, object-oriented JavaScript on the assessment, they are crucial to understand because React is written mostly with the class syntax, and it will leverage heavily on this. If your understanding of this is not rock steady, it will hurt you in React. Cool? And I will go over this again next week. So I want to close out with one more thing on this. I'm going to answer that question. But I want to end it that later this afternoon, Andrew's going to finish a review. Next week, all right, because we have Monday off, I'm going to give you the Rails API lecture I did last time. Please watch it. I will host a Q&A on the Rails API on Monday morning, and then Jason, right, will give you the refactor any lab from functional programming to oojs, so you can kind of see it happen live, understand it, ask a million questions in that lecture. It's going to be so useful for you. And this is going to be on Tuesday because Monday's off. So you'll get the Rails API over the weekend, watch it, Q&A in the morning on Tuesday, the refactor Tuesday afternoon from a functional to object-oriented. Cool? So the last thing we had was Ruby. I'm sorry, you had a question.
When you're writing these OO like structures out, in Ruby you're putting them in different files. Is that a big similar, or is it just one long, you need to organize it in blocks of classes?
There are different schools of thought as to how to organize your JavaScript code, but generally speaking, when you start doing classes, those are self-contained, and they will generally get their own file. Like in this, I would have my own JavaScript file called character.js, and it looks a lot like this, right? Character.js, cool? And then I would put all this class syntax in there. We're not going to get to that today, but that's a school of thought. If you're curious, check out the Airbnb JavaScript style guide for any questions on that. If you still have a question after referencing that, we'll take it. Cool? So, last thing I want to do is, here, I can easily just go private, right, and just go, oh, look at these strong params, or something like that, right? Remember this? Am I adding an extra n somewhere? Thank you. Too much JavaScript. Yeah, it's hard to jump between languages. You'll see. Cool, right? How can I create a private method or private variable in here? No, use strict is different, and we can talk about that offline. We did this several times already. Do you remember the discussion question where I can have like let some array equals to like an empty array? And then somewhere in here, I don't know if I wanted to, but in the constructor, all right, I can do this dot, I'm sorry, no, it's not gonna work. I can do the array plus plus. I can like increment the array. Sorry, cool. I'm really zoning. Right, it's like how we did IDs. IDs is better. Zoning out, right? In the constructor, right? In the same way that initialize gets invoked on the .new, this new character will create a new object and invoked the constructor and point the prototype to the class. If this is getting invoked, right, I can create a closure, right? Right, like const closure equals closure equals to what? A function. Cool. Is that all I have to do? Yes. Right? What else? Well, closure now is going to be a reference to this function. I have to invoke it, right? Do you remember ifs? I think Andrew went over ifs, right? I should invoke it. Can I invoke it like this? I want to define it entirely, wrap that whole thing, and then invoke it. Because what happens when I invoke it is that it sets this variable, then simply returns this, and then I no longer have access to ID. We've seen that in the discussion question. We've seen that in previous lectures. Because it gets returned, there's no longer access to this. So this is how I can create like a private variable inside my class by wrapping it inside a closure and then immediately invoking it, because when I return the function, it has access to this and no longer access to this. Got it? So are there questions on how to do object-oriented JavaScript, class methods, private variables or functions inside a class syntax? I'm gonna stop right there for a second. Are there questions on that first? Because I'm gonna pile on a few more.
And so, I don't know, once you call this, given character class exists because you invoked it, basically? So you can
No, character class does not exist. I have to always invoke this. I would put like character class here, const character class. Right, and this would like create the closure. And then I would just put new character class, right? So, are there any questions on that, on OO? The more important thing right now is understanding the prototype, the difference between underscore, underscore, proto, underscore, underscore, the dot prototype, how the new keyword works. Object.create does not attach the constructor as the prototype, and the prototype chain. Awesome, great, that's all I have.